Ready. So good evening all of you. So there is no summary of last lecture. We are going to start a new summary. So take a fresh book and fresh notebook, fresh pace, and take the heading. Classical mechanics. Classical mechanics. So what is this classical mechanics and why we are studying here this one? Actually here we have three parts. First one is Newtonian mechanics, and the next one is Lagrangian dynamics, and the next one is Hamiltonian dynamics. The Newtonian mechanics, from intermediate onwards you are studying the same thing. Okay, so let us start with this Newtonian mechanics, because without Newton I think this is not fulfilled I think. So let us start with this today, Newtonian mechanics. Newtonian mechanics. Right. So very first one, I am going to start Newton's laws of motion. Newton's laws of motion. So these are basic things, ma. Let us start from the basic only. I hope very long back you have studied intermediate. Let us recollect all those things. So what are these Newton's laws of motion? Which describes the dynamics of a body. Which describe the dynamics of a system or a body, something like that, whatever it is. Good. Let us start the first one. This is the first law. Can anybody tell me what is this first law? Law of inertia. Law of inertia. That means, now for example, there is a particle. Let us say this is a free particle. So why I am saying about a free particle? If I say free particle, there is no interaction, there is no force on this particle. Say yes or no? Yes, now let us say this is a free particle. That means there is no force. Then what will happen? If it is already at rest, it will be in the rest only. If it is already in motion, it will be in that motion only, unless it is compelled by an external force. Unless and until if you exert some external force on that body, then only it will change its state of motion. That means, for example, this is the body of mass m which is at rest. Or else let us suppose this is a mass of m which is moving with a velocity v, that too constant. That means which motion, ma? Uniform. You know already, just try to recollect. The statement is very simple. A body is continuously in its state of rest or uniform motion, not simply motion, uniform motion. Why uniform motion? No force. If the force is there, the velocities keep on changing, then it is accelerated motion. The meaning of this rest or uniform motion in both the cases, no external force. The state of rest or of uniform motion until it is compelled by an external force. That's good. That's it. And second one, this is the second law. What is second law? Equation of motion. Yeah, equation of motion. That means, let us suppose here is a body of mass m and some external force is there, F. Then the body is having some velocity v, but this velocities keep on changing. So according to second law, I hope you know, the external force F equal to rate of change of momentum. Say yes or no? Yes. That's it. And this can be written as m dv bar by dt plus v dm by dt. But generally for all our problems, for all our applications, we will take m is a constant. That's why this is equal to m dv by dt, which is equal to m a. That's it. So this is the equation of motion. If anybody asks what is the equation of motion, what you will say? F bar equal to, but wrong. This is up to 9th class, 10th class equation of motion if F equal to ma. You are in MSc student. What is equation of motion? Poisson's equation of motion. dA by dt equal to Poisson bracket a comma h plus dou a by dou t. Just like a Heisenberg equation of motion in quantum mechanics, the same thing you have to, similar thing you have to say. Anyhow, that's it. And this is about second law. And let me write the third law here. Although you know we have to start with this big boss only, okay, Newton, right, third law. So let us suppose here is of course this is a action and reaction, reaction. Now let us suppose here is a mass m1 and let us suppose this is a mass m2. Now m1 is exerting some force on m2, similarly m2 will exert some force on m1. The notation is this is the F bar, force acting on 2 by 1. Now this is the force acting on by 2. The first index indicates on, the second index indicates by, which body, which number, something like that. That's it. And these two are in the opposite direction. That's why F12 bar equal to, that's it, which is action and reaction pair. Both are acting on same body or different bodies? Different bodies. Action and reaction acting on a same body never be action and reaction. Action and reaction must priority, first priority is must be on different bodies. This is the action you are exerting on this bench at the desk, and again that will exert force on this, like that. Okay. So action and reaction are not on same bodies. It is different. Come on. Few basic concepts I would like to discuss, and after that I will enter into the application. CSIR around 35 marks weightage. Oh, 1 minute. a body is continuously in its state of rest or of uniform motion until it is compelled by an external force, And second law is the equation of motion, F equal to ma, that is actually F equal to dp by dt, but m is a constant. And third law is about action and reaction pair. Both are not acting on the same body, it's two different bodies. Two equal and opposite forces acting on a same body is what? Two equal and opposite forces acting on a same body. Huh? Equilibrium. What is meant by couple? Coupling kaadu, couple. Ready. Note. Please write that. You said same body, action and reaction, that is not on the same body, it's acting on two different bodies. Note. Newton's laws of motion are valid in inertial frame of reference. Inertial frame of reference. Now let me explain what is meant by inertial frame. Anyone? I think in the school level you studied it is a not accelerated frame. Am I right? A frame which is at rest or moving with the constant speed is called inertial frame. But you are MSc, how to change the definition? Galilean transformation.
Some transformation is invariant for inertia.
What is that? Listen. Inertial frame. Inertial frame means a frame of reference. Listen carefully. A frame of reference. Now, for example, now I am taking one frame of reference, this point. I am taking this point of reference as a frame of reference. It means I am observing the motion of the fan with respect to my frame of reference. That's why this is my inertial frame of reference. Now I am observing that. But this inertial frame should satisfy three conditions. One is a frame of reference whose space is homogeneous. Space is homogeneous. Means what? I will tell you. Now I am standing on the dais. Now I am standing here at this point and I am observing the speed of the fan. Now I translated my position. Again observing the speed of the fan. Any change in the properties? That is called homogeneous. So if you want to say this frame is an inertial frame, it should satisfy the first condition. Space is homogeneous. Although you translated from one point to another point, you are observing a car motion, Babu. A car is moving with the speed v. You are observing at this point and you travel some distance. Again you are observing. Any change? No. No. If it is moving with the same speed, no, there is no change. because of changing your position, the properties of the system do not change. That is called space is homogeneous. Next, second one, space is isotropic. That means whatever may be the direction of measurement, now you are measuring in this direction, you got one value, and you change the direction, its value never be changed. That frame of reference is called inertial frame of reference. That property is called space is isotropic. And the third one, time is homogeneous. These three properties satisfied, then only it is called inertial frame of reference. A frame of reference whose first one, space is homogeneous. Second one, space is isotropic. Third one, time is homogeneous. If a space is homogeneous, then linear momentum is conserved. Constant. Space is isotropic. Angular momentum is conserved. Time is homogeneous. Total energy, it should not say energy, total energy is constant. So, Newton's laws of motion valid only when there exists linear momentum conservation, angular momentum conservation, total energy conservation. If you just go back to a few years back and if you see in intermediate, all of your Newton's laws of motion problems, you will apply either law of conservation of momentum, law of conservation of angular momentum, law of conservation of total energy. Without these three things, it's not possible to solve that Newton's laws of motion, Newton's problems. Problems based on the Newton's equations, Newton's laws of motion. So that means Newton's laws of motion are defined for which frame? Inertial frame means a frame in which linear momentum is conserved. Conserved. Angular momentum is total energy is. So linear momentum is conserved. Angular momentum, please learn this at least it is easy to teach to your children at least in intermediate. Conserved. And this is total energy is conserved. That's good. So then that frame of reference is called inertial frame of reference. Galilean transformation, Lorentz transformation is also defined for inertial frame only. Only the difference is Newtonian mechanics, space is absolute. Time is absolute. Galilean transformation, Newtonian mechanics, both are defined for inertial frame, but a small change. Newtonian, space and time are absolute. Galilean, space is not absolute, time is absolute. Lorentz, both space and time are not absolute, but all the three things are defined for inertial frame. Special theory of relativity. That is inertial frames. General theory of relativity will talk about the non-inertial frames. Okay, anyhow, come back. So that's it. I hope you understand the first definition of inertial frame and next, second point. Now, let us say what is meant by conservative force, because these are the terms we will use frequently, conservative force and central force. I am explaining each and every terminology, please listen carefully. Central force. What is meant by conservative force? Now let us suppose F bar is a conservative force. Conservative force. Then what will happen? There exists a scalar field. There exists a scalar field, let us say U, such that Come on, that f bar can be written as negative gradient of scalar. Then only we will say f is a conservative field. For every conservative field, there exists a scalar field which is and a force is the negative gradient of a scalar. Is that clear? Negative gradient of scalar. Super. Wait a minute. Ma, listen careful. Actually, there is a result, a null result. Means answer is 0. What is that? CGS equal to 0. What is CGS? C for curl, G for gradient, S for scalar. Combine. Me bonda. Curl of gradient of scalar. Curl gradient scalar. Curl of gradient of scalar. Right. That means del bar cross del scalar. Here scalar is what? U. Is it clear? Okay. First let me write 5 equal to 0. This is the null result. One more null result is there. DC voltage. Vector. DCV equal to 0. Another one. You won't forget this, I think. CGS 0. DC voltage 0. Na? Right. This is the divergence. Del dot curl of vector is always. These are the two null results we have. Okay, fine. Now come back. Now I am taking this f bar equal to minus del u. Just I am applying curl on both sides, ma. Del bar cross f bar equal to del bar cross minus del u. Could you please tell me what is this? Curl of gradient of scalar. How much? So F is what kind of force, ma? Then its curl is. That's good. Next. Next one more point is the center. Just I am introducing all the points, that's it. All the terms. Central force. What is this central force? Now, for example, here you have a frame of reference and here is a particle of mass m, okay, and which is having a position vector. Let us say the position vector is what? R. And let us suppose some force is acting on this. How much, ma? F. Now this F bar equal to F of R, R cap, whose magnitude depends on R only and the direction is along R cap. But this R cap may be positive or may be negative. What is the meaning of positive? Positive R cap means away or towards? I mean, this is the origin. Positive R cap means away from the origin or towards the origin? Away. Positive R cap? Away. Negative means? Towards. Now tell me, something is going away means, is it repulsive nature or attractive nature? That's it. Repulsive force. Negative R cap? Attract. Remember one thing, magnitude is not negative, direction is negative or positive. The best example is gravitational force. So we will write that later, example. So what is this, plus R cap? Minus R cap? Good, that is the central force. And if you observe carefully, F bar equal to, you have written F of R cap. Now shall I apply curl on both sides again? Del bar cross F equal to del bar cross F of R, R cap. I hope some of you remember. Del bar cross R cap equal to a radial vector never bend. Okay, curl, okay, 0. So that's why central force del bar cross F bar, 0. Conservative del bar cross F bar. 0. That's why every central force is That's it. Clear? Try to recollect. Just we have defined the Newton's laws, and after that Newton's laws are valid in inertial frame, and we define what is meant by inertial frame. A frame of reference whose space is homogeneous, whose space is isotropic, and whose time is homogeneous. But unfortunately time is not isotropic. If time is isotropic, what will happen? We can go back to past easily. No, it's possible, but it's not possible. Anyhow, time is not isotropic. God has given a chance to you to go to the past and change one thing. What you will change? Taking MSc Physics, huh? Huh? Again study one standard, 12th standard, okay. 12th standard. Why? Boys, for you? Huh? Sorry? ఏంటి freedom fighter. Which class you will change? Intermediate, na? BSc. Ready? Right. The next one, force, work and energy. So earlier we have introduced what is meant by conservative force, because very frequently we will use that word conservative and a central force or something like that. Okay. And the next one, force, work and energy. How these things are related, all of you. Now for example, I have a frame of reference. Let us say this is the inertial frame, no doubt, x, y, z. Now here is the particle and it's moving just something like this. At a particular instant of time, this is the position, this is r bar ta, that means this is the time. At what time? Ta. It is at the point A, let us suppose. And after some time, the particle is coming here, that's why this is the position vector at what time? Let us say Tb. Now this is the point Tb. This is the position vector at A, this is the position vector at B. If anybody asks what is the instantaneous vector, then you have to say r bar of t. T always stands for instantaneous. At a particular instant of time, you are finding its position, you are finding its velocity, something like that. Good. Now the particle is moving like this. Very nice. I hope if the particle is coming from here to here means some work is done on the body. Say yes or no? Definitely. Without work, it won't move. So if you keep it there, go and it won't go. You have to apply some force, and due to that some work is done on the body, and that body will move from one place to another place. Okay. Now I hope everybody know what is the definition. dW equal to F bar dot dr bar. dr bar. Because this is the dr. F bar dot dr. Cool. Amma, listen carefully please. Don't neglect the basics please. So this is F bar. Now what I am doing is just I am writing dr by dt into dt. Shall I? Okay. Could you please tell me what is the dr by dt? F bar dot v bar into dt. Now this is the work done. Okay, nice. And I think if I want to find the work done, simply I have to do the integral f bar dot. If you, with your permission, I will write it as f bar dt dot v bar. Shall I? Right. Now carefully observe what is this. Change in momentum. Why you are getting tension? Now see, what is the definition of force? Rate of change of momentum. That is nothing but dp equal to what? F bar dt. So I can write it as the impulsive. Impulse is nothing but what? Change in momentum. So F bar dt is nothing but dp bar. So this can be written as work done equal to integral dp bar dot v bar. And you know what is the momentum? Mass into velocity. That's why I am writing mass outside. Integral dv bar dot v bar. And v bar dot v bar, same direction na? V bar and dv bar direction both are same. That's why work done equal to mass integral v dv. Is that clear? A bar dot a bar, something like that. Say both are in the same direction means theta equal to 0, then cos theta equal to 1. I hope I need not to say. And here it is u and here it is v. Or your wish. V initial, v final. I think this can be written as half m vf square minus half m vi square. Everybody understand? What is this v integral? V square by 2. M v square by 2 from v initial to v final. That's it. Now finally here what you get, the work done is equal to, this is the final kinetic energy and this is the initial kinetic energy. So the change in the kinetic energy is nothing but the work done. Understand the derivation? But now one more, a small note. Now already we have defined F is a conservative. I am defining that F is a conservative. If F is a conservative, there exists a scalar potential just like F bar equal to negative gradient of U. Say yes or no? Now again I am taking the definition. The amount of work done dW equal to F bar dot dr bar. Again I am taking F bar, this time I am taking it as a minus del U dot dr bar. Now just integrate W equal to minus integral del U. Del U is nothing but dou U by dou R cap. Why? Because R cap, here what you have? dr bar. dr bar is what? Although other terms are there, all the dot products will be 0. Understand? Now this is a minus integral R cap dot R cap dr. Come on. Integral du. So this is nothing but, let us say, initial, and this is now this is minus integral du. From where to where? Understand? Now the work done W equal to how much? Minus of UF minus UI, which is nothing but UI minus UF. So what is the relation between work and energy? Work is change in kinetic energy. Work is negative of change in potential energy. The reason is always change by default will take final minus initial. This is simple. Why minus is there? If one thing is increasing, another thing must be decrease. That is the reason why the minus is there, because the total must be always constant, because we are in the inertial frame. That's why total energy must be conserved. And is it okay? Because all these are basics, that's why I'm going fast. Is it okay? I think both are equal. Tf minus Ti equal to Ui minus Uf. If you rearrange the things, I think you will get Ti plus Ui equal to Tf plus Ui. Could you please tell me what is this? Law of conservation of energy. Is it clear? Nothing, no need to worry, just TW formula and F is minus del U. Del U will be having R theta, something like that, but we have only dr bar here. That's why only R cap term remains, remaining all gone. That's why del U, integral is U. That's it, simple, very simple, do it yourself. And here a small thing, F dt is nothing but impulse, which is a rate, change in momentum, not rate, change in momentum. Every CSIR, they are giving one question from Newton's laws of motion. It's a definite question. Don't copy, do it yourself, then only you will get confidence. By seeing the problem should get fear. You should not get fear. Ammo, she will solve that problem. That's like that. Sorry? Huh? No. It's okay. No, it's okay. There. Okay, okay, understand. Now it's okay? Remember, there is one definite question from Newton's laws of motion. That means we have to use F equal to ma. No doubt, already we have done some questions in the mathematics. Where? Differential equations. For that reason only we started from Newton's laws. One question damn sure, no doubt, definitely they will give in just exam, in TFR exam, in CSIR exam. Definitely this question will be there. How to apply F equal to ma. Ready, Amma? It's okay. No. That top one it will be like that only. Light is there, na? That means so much light is falling on that top. Ready? All of you stop and see the board. This is a very, 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 very important, definite question, no doubt about it. So listen carefully, please learn, please learn. How to apply F equal to ma? First of all, you please see this acceleration. What is acceleration? A bar equal to dv bar by dt. One form. What are the different forms of acceleration? Acceleration A can be written as dv by m kadamma dv by dt. Next another form. Wait. A equal to, you can write this as dv by dx into dx by dt. Say yes or no? Yes. That's why dx by dt can be written as v, come on I say. So another form, A can be written as acceleration, acceleration, acceleration. Another one, what you are saying, acceleration equal to d square x by dt. These are the three different forms of acceleration. Once again, A, V dV by dx. Another one, A d square x by dt. Why these forms are required? Listen. If this is the body of mass m, on this some force is exerting, that means some force is applied, and you are studying the dynamics of this body. What is the meaning of studying the dynamics of the body? You are finding the velocity, how it is changing with respect to time. You are studying the displacement, how it is changing with respect to time. Almost all the problems you have to find two things. One is V of t, another is x of t. Any problem, these are the two things you have to find. That is why first you have to know how many types of forces are there. Types of force. I am not explaining the problem, I am explaining how to solve. If you understand this, any problem you can solve. Please listen, please listen. Types of forces. How many types of forces are there? Okay. The first one, constant force. Constant force. Can you give one example for constant force? Can you give one example for constant force? In the time lag. If you are not giving any direction to your brain, it won't give you the answer. Always you have to, what do you say, ignite. Always you have to send the signal to it, then only it will tell you. Very simple, somebody will say, somebody will clear the exam. So example, gravitational force. Gravitational force. Because if you are saying the answer, it will give you so many advantages. First thing is confidence. You will understand, oh, I remembered, first of all. And whenever you see something, you won't get a fear. I forgot, I remembered, I forgot. Because if you are giving the answers, then only you will get confidence, otherwise no. Gravitational force, that is F equal to how much? mg. Now you are having a constant force. Okay, fine. So how to handle this? Very simple, Amma. Whenever you have a constant force, this is the method. Take F or F bar, whatever it is. F bar equal to how much? That's it. Now just cross multiply. dV equal to m dV equal to F dt. Just cross multiply and then integrate. M is outside, integral dV, F is outside. Why F is outside? Constant. Now generally V changing from V initial to V final and T changing from, that's it. Clear? That's good. This is the process. Sir, from this what you will find? You will find velocity, V of t you will get. Once you got V of t, I would like to find x of t. How to find x of t? V of t is always equal to. Again what you will do? Cross multiply. Dx equal to something into dt, integrate. What you will get? X of t. That's it. So, sir, how we will know whether the force is a constant or not? He will explain in the question. Gravitational force or some constant force he will define. Then simple, very simple. F equal to m dV by dt. Cross multiply and direct integration. F will be outside, m will be outside. Can you do it? Next one. Second one. Position dependent. Means your force is position dependent. That means F of x. Example. Central force minus kx, elastic force. Example, F equal to minus kx. If it is a position dependent, how to handle? Are you ready? Yes, sir. Right. Now how to handle this? Again same, F equal to m dV by dt. But unfortunately, our force is not constant and not time dependent. It is. That's why the variable must be in position. Now we are going to change this. M, I told you already, dV by dx into dx by dt. Please follow this. Now F equal to m. What is dx by dt? V dv by dx. Now see, now cross multiply. Your f is a function of x. Just cross multiply. M v dv equal to, if you write d square x by dt square, it won't work. Why d square x by dt square won't work? Again cross multiply f dt. Understand? It's wrong at all. So whenever force is position dependent, then immediately you have to take acceleration equal to. Clear? That's it. That's it. And now m is outside. Integral v dv equal to integral f of x dx. Please follow this pattern. Please follow this method. Then from this, what you will get, ma? V. V you will get. After that, again dx by dt you can find. Clear? Next, constant force over, position dependent over. Next one, time dependent. Time dependent. If the force is time dependent, that means f of t. Best example, if you want, f is equal to minus qe cos omega t. What is this? Minus qe naught cos omega t. Is it okay? Right. Something like just example. Now ready? Time dependent. Time dependent. Now f equal to m dv by dt. So what you will do? Just cross multiply, nothing else. F dt equal to m dv integral v initial v final 0 to t. What you will get, ma? V. Once you got v, what you will find, ma? Dx by dt. And from this, dx is equal to something dt, and as usual x equal to something. Clear? The force is a constant. Directly take F equal to m dv by dt. Position dependent, F equal to m dv by dx. Next, time dependent, F equal to m dv by dt. D square x by dt square don't take. Why? It's a second order differential equation. It's difficult to solve. All these are what? First order differential equations. Okay? And most of the problems will get these type of integrals. Integral f dash of x by f of x. Answer. Very few people are saying integral f dash of x by root f of x. Answer. 2 root f of x. Maximum these type of integrals we will use here. And the third one, I think tan inverse also somewhere we will use. 1 by x square plus a square dx equal to 1 by a, something like this. This type of integrals we will use. Are you ready? Next, what we are going to do? Problems. Sorry? G is constant. If you take G is a constant, then only constant force. Otherwise, if you take G is varying with respect to height, that is a different. What we are not sending any rockets now. We are throwing a ball here, and G is a constant one. Constant force, position dependent, time dependent. Oh, one more is there. Velocity dependent. There is no space. You please write velocity dependent. Same. Just variable separable. F of v equal to m dv by dt. F of v will come this side, dt will go that side. That's nothing else. Try. Otherwise, I will explain. just variable separable, first order differential equation. One more force is there, velocity dependent. Try yourself, after that I will write here. Maximum you will get a velocity dependent question only, maximum. Most of the time they have given this only. You try yourself. Integrations I will write here. Just make it variable separable. F of v equal to m dv by dt, bring that f of v this side, bring that dt that side, that is it. M also will go that side, I think. 1 by m integral dt equal to integral dv by f of v. Only these are the 4 applications based on Newton's laws of, Newton's equation of motion, either constant force or position dependent or time dependent or velocity dependent, nothing else. So here f of v equal to m dv by dt, very simple, just make it variable separable that means dv by f of v, bring this f of v this side and bring that m that side, 1 by m dt, that's it, over. So this is a very important. Whatever they have given f of v, we will substitute, that's it, nothing else. And the limits initial to final, they will mention in the question, and time limits always 0 to t only. Once again, f is a constant. How we will start? F equal to m dv by dt. F is a position dependent. How we will start? F equal to m v dv by dx. F is a time dependent. How we will start? F equal to m dv by dt. F is a velocity dependent. How we will start? F of v equal to m dv by dt, but variable separable. Then dv by f of v equal to 1 by m dt. And d of t. Ready? First problem. Problems based on f equal to ma. If f is a constant force, first problem, if f is a constant force, if f is a constant force, determine the velocity v of t, the velocity v of t and the trajectory x of t, and the trajectory x of t of the body. Yeah, just I will start, you can finish it. Amma, here first you please write whether f is a constant, position dependent, velocity dependent, time dependent. F is then what your sir said, f equal to m dv by dt. Now just cross multiply, m dv equal to f dt. Now this is m outside, integral dv equal to f outside. Why f outside? Constant. From where to where? From where to where? Fine. Generally in the problems what they will consider, initial always v naught, final they will take v of t. That means you are finding the velocity at a particular instant, that is why v of t. Generally, okay, v of t. Okay, so this is m, dv, v from where to where? Equal to f t. Now this is nothing but v of t minus v naught equal to f by m t. Now v of t equal to v naught plus f by m t. If they are asking any graph or something like this is the time and this is the velocity. Okay, so at a time t equal to 0, what is the velocity? That means 0 or non-zero? How much? After that, how it is changing with respect to time? Proportional? Proportional means what? Straight line. That's it. And after getting v of t equal to v naught plus f by m into t. I told you how to find x, v is nothing but equal to v naught plus f by m into t. Now cross multiply, dx equal to, is it okay? Integrate, generally initial, final, x of t. That's why so this is x of t equal to x naught plus v naught t plus a half f by m t square. If anybody asks to draw the graph, now this is the time and this is x of t. Whenever you are drawing the graph, always remember one thing, put t equal to 0 first. Put t equal to 0, then what is the value? Some value is there. Now, how it is varying with respect to time? How it is varying with respect to time? T and t square. Which is dominant? T square. So what is that? Parabola. Parabola like this, No, like this. Somewhere it will be 0 also, somewhere. Is it possible to get 0? Why not? At a particular time, if you equal to 0, then you will get some time value, maybe somewhere, we don't know where it is, but maximum also you will get somewhere. How to get the maximum? You have to differentiate it and you have to do all these things. But the curve will be like this. That's it. Can you do it? Don't copy. I'll give the problems one by one. Please start doing. Oh, I think this is wrong. This is wrong. I'm sorry. Upward only. I'm sorry. This is a t and a t square. I think it will go upward only. They have given like this only. Where is the t? This one t. I don't know. They have given this diagram only. Domination is a t square. Oh, okay. AT minus bt square downward plus bt square upward. Don't copy, don't copy. Do it carefully. Don't get tension. Aram se. Constant over. Now time dependent. Second and third time dependent. At least do the second one. Third one, if you want, I will explain. Please learn applications. Please learn application. Everybody know F equal to ma. But how to apply, that you should learn, because you came here. Just variable separable and a small integration, not at all difficult. Please do it carefully. First order differential equation, variable separable. Next one, f of t given. F of t equal to m dv by dt. Just cross multiply, your job is done. Don't copy, don't copy, do it yourself. I hope this one is completed. Just cross multiply, I mean variable separable, m dv equal to f of t dt, integrate, integrate, and m outside, this is v of t, generally v naught and v of t we will take because here it is a time, v of t minus v naught equal to integral f of t. What is f of t? A minus bt. I hope you are copying. Are you copying? At minus half bt square. So you can find v of t equal to how much, Naina? V naught plus 1 by m into at minus half bt square. Next, immediately go for v is nothing but dx by dt. Come on, be confident. Just again cross multiply. A by m into t minus a half b by m into t square. Now again just cross multiply, dx equal to, I hope you completed, v naught plus a by m into t minus half b by m into t square dt. Now integrate, integrate. Those who have completed, go to the third question. F of t equal to f naught cos omega t plus phi. Aram se do it. Do one problem yourself, you will get confidence. You will get confidence. Go to the next question. F of t equal to f naught cos omega t plus phi. Same. Find v of t and x of t. Come on, speed, speed. Already 2 months onwards you are doing the integrations. Completed, Amma? Those who have completed that, go to the next one. Say f of t equal to f naught e raised to minus lambda t. Same, find v of t and x of t. Please learn, please leave it, don't leave it, don't leave it. Struggle. If you leave one thing, 100 things are ready to leave you. I hope this also completed. F of t equal to m dv by dt. So m dv equal to f of t dt, integral, integral. M outside, this is a v of t minus v naught, always integral dv is v. Now integral f of t, that is f naught cos omega t plus phi dt. If anybody is still not completed, f naught outside, and this is from 0 to t. Cos integral is what? Sine omega t plus phi by omega. I don't know whether you have written by or not. And from where to where means 0 to t. So this is f naught by omega. If you substitute the upper limit as usual, Amma, if you substitute the lower limit, how much it is? Sine phi. Careful. So finally, I think you got V of t equal to V naught plus F naught by m omega into sine of omega. If you copy, you will struggle in the exam. Do it yourself. Do it yourself. Again, take V of t is a dx by dt and one more time integral. That's it, nothing else. It's not a difficult integral, cos integral, sine integral. If you are having confidence, you won't get any fear. If you are getting fear means no confidence, try to get the confidence by solving at least one problem. At least one problem. This is again dx by dt. So again cross multiply, dx equal to v naught plus f naught by m omega sine of omega t plus phi minus sine phi. మీరు టెన్షన్ పడకూడదు, ఈజీ ఇంటిగ్రల్స్, ఆల్ ఆర్ ఈజీ ఇంటిగ్రల్స్. వి నాట్ ఇంటిగ్రల్ వి నాట్ టీ, ఎఫ్ నాట్ బై ఎం ఒమేగా, సైన్ ఇంటిగ్రల్ మైనస్ కాస్. Just this also very easy, cross multiply, f of t equal to m dv by dt. Just cross multiply, please do it yourself, please do it yourself. M dv equal to f of t dt, integral, and this is a v naught and this is a v of t. This is m v of t minus v naught equal to integral f of t, f naught e raised to minus lambda t dt. From where to where? 0 to e raised to minus lambda t integral is very easy. What is e raised to minus lambda t integral? E raised to minus lambda t by minus lambda. Substitute the limits. Whenever minus sign is there, which limit you will substitute first? Lower limit. I think you will get 1 minus e raised to minus lambda t something. After that again proceed, find x of t.